And you're back with Mr. Canada today, and we're working on inequalities. Sorry about that. So we're going to look at what happens when we have an inequality. What does this actually say? So what actually does this mean, right? So I don't really have any preamble or any kind of notes on this because it's often just best described in examples. So how can we best describe this? So just write down exactly as you would read it left to right, just as a book. So, what do we say here? We say y, and then, well, what's the next thing? That is y is less than, right? That's our operator. And then we have 7. So that's literally what it says there, just in words, right? That's our operator, that's the number, that's our variable. The only thing we're missing is, well, we want to make it sound like a sentence, so y less than 7. So y is less than 7. That is that. So, next one, same thing. A, well, that's greater than, what's it greater than? It's greater than -2. Okay. Once again, just have to make it grammatically more correct. The next one, we have x, and we have less than or equal to -4. So same thing, x, and we're starting to see that we need that is all the time, is, and then our operator is less than or equal to -4. And so where this is going to start helping us is if we can kind of start to spell out and start to realize, well, if this is a is, well, let's start with the top. Y is less than 7. That means if we start at 7 and we just count backwards, and we can just kind of say we're going to continue with some dots. Well, y is less than 7, so wait a sec, we can't include that 7. So we know that y is just going to be 6, 5, 4, and it's going to continue on. Similarly, with the next one, a is greater than -2. We have -2. Well, greater than -2 is going to -1, 0, 1, 2, and so on, right? But then we look, oh, it can't be -2, so we'll cross it out and say, hey, those are our integer values. After that, looking at one that has, hey, what about this less than or equal? These ones I find are actually easier, so we can list out -4, -3, -2, dot, 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 dot. And this time, well, it is less than or equal. So we can keep this -4 this time, the starting number. So this is kind of the idea, right? So if it keeps going on forever, just indicate with a dot, dot, dot. If it's something where we're enclosed in some values, which we'll come into eventually, then you'll kind of see where we go with that at that stage. Last example we're going to do is -4 is greater than or equal to x. I've always found that these are kind of, it's just awkward. So what we can do is we can actually swap these two around. Okay? So if we swap those around, so we can say x something and -4. Well, if -4 is greater than or equal to x, right, that means x has to be less than. Or if you want to just look at where x is, and you can define it by that. So it has the little point of our operator pointing towards it, so x is less than or equal to -4. So I just like switching them around, and typically when you answer problems, they're going to be stated as x, y, z, a, b, c, so on, and then their operator. So knowing that, then we can just quickly say x is less than or equal to -4. That also allows us to know a little bit more about our situation, because we don't care about the number. We care about what x is doing in respect to 4. We don't care what 4 is doing, right? It's great that negative 4 is bigger than or equal to x, but that doesn't help us. So we have 8 problems here, so try and explain them. Pause the video. Once you're ready, then press play and I'll go through the answers. Okay, so first one, we can say x is less than 4. And I'm actually going to write out the numbers as numbers just to save a little bit of time. Usually that's actually kind of okay to do as well. So y is greater than or equal to 10. And keep going, right? Make sure you state always with your variable first. That way it actually helps us describe it a little bit better. So you can either flip it around backwards and then do it, or you can just do it right from looking at it. So here I'm looking at my x, and I have the operator spread apart here, so I know that's the greater than side. So x is greater than 7. Similarly with the next one, we have x is, this time it's pointing towards the x, so x is less than. We have the line underneath, so that means equal. So x is less than or equal to negative 7, which means it's negative 8, negative 9, negative 10, and so on. So getting off to the right side, here we keep in mind when your variable changes, that changes as well. So don't be fooled and put the wrong letter and start talking about x's when there's no x's in our question. So y is less than or equal to 5. And then continuing on, this all of a sudden doesn't really look like too much of an inequality, but it's not one that we typically use too much, but it's still, I like always putting one of these in here to show you what this sign means. This just means that x cannot be 3. Okay, x does not equal 3. So x does not equal 3. So that means that x is every other value that we have. So it will be 0, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, da 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 da. And similarly in the other direction, 0, negative 1, negative 2, negative 3, negative 4, and all the negative values, off into negative infinity. So x does not equal 3 to finish that one up. These two are where we kind of start going with inequalities in the future. So how can this is kind of a boundary value problem, or better, it's bounded on both sides, right? So it means that we're kind of it's not going to go off to infinity. It's not going to go forever. So what is it actually going to say? We'll look at it one at a time. So x, so we're always going to start with x. So x is, and you can pick and choose. I'm going to pick and choose and start with my leftmost, right? That's how we read a page. So x is, well, what's x doing with that 7 chunk right here? Just look at that. So you can just do it by covering up with your finger, the 10 for the first thing. So x is, well, it's greater than or equal to 7, right? So we're done that first part. And I'm going to do this in a different color. So, and now we want to look at the part in red here, right? So we're going to cover up the 7. What's x doing at that point? Well, here, notice that it's less than, right? Because the point is pointing towards the x. So, and x is less than or equal. Sorry, that's not a really good than. Less than or equal to 10. Okay. So when you see the bounded on a variable is bounded on both sides, so there's a number to the left and to the right, and two inequality operators, just separate them so you're working with just the left and the letter, and then just the right and the letter, and just break them into two problems. Just put an and between them because it's just saying it follows both these rules. The rules aren't related, but they have a similar thing in common, which is x. So, knowing that, let's do the other one nice and quick here for number 8. So, we have, and I'm going to write the opposite way. So, x is less than, and I'm just going to go slash equal to -2 and greater than or equal to -5. So, right. We will look at this further when we get to kind of representing these on graphs and what we can actually work with inequalities. But for now, we're just going to stick to working with kind of a single inequality and work our way up.